Most students really, yeah. Most of the students love this one a lot. Or love to hate it. So, on this one, what I recommend doing is just focusing on numerators and denominators. Don't worry about, hey, we're going to change this to multiplication. That will happen. Just don't worry about it yet, okay? So, here's what I'd like you to do, just for now. Just don't worry about the denominator, all right? We'll get there. We'll worry about it. Just not yet. Just not now, okay? So what I'd like to do is I'd like to focus on just the numerator for now. And what I would like to do also is take that numerator and I would like to make the denominators match so that I can perform the subtraction, okay? So we did see problems like this in one of the previous sections where it said, hey, go ahead and simplify this garbage. And we've seen how to do that, okay? So I guess I need a little bit more space there, but I need the denominators to match, right? So this is where I take one of the denominators and I multiply it into the other fraction, okay? So here's what I mean by that. I'm going to take my x plus 1 denominator. I guess really I should put everything into parentheses, but I'm going to multiply it into the other fraction, both numerator and denominator, right? So, so I got my x minus 2 denominator, right? I'm going to multiply by the other denominator, x plus 1, right there. But again, if you do it to the denominator, you got to do it to the numerator as well. So that's an x plus 1. Okay. And as fun as that looks, I'm just going to keep it that way for now. We'll come back to it though. Because I'm going to take the x minus 2 denominator and I'm going to multiply it into the other fraction. Okay, both numerator and denominator. So if I multiply the denominator by x minus 2, which I am doing, I'm also going to have to multiply the numerator. Now, having done this and showed it, the orders are different. I've got x minus 2, x plus 1. Oh, I guess the orders are the same. My bad. So the denominators match, though, okay? Since the denominators match, they are the same. I don't care if they're the lowest common denominator. They're just common, at least. At least that allows me to actually perform the operation of subtraction. So the next step that I'm going to show in this problem, some students choose not to. Some students choose to do it, okay? But it's completely up to you. What I'm going to do here is I'm going to take, since we have a common denominator, in fact, what I'm going to do is I'm going to make this line bigger because I think I'm going to need it to be. But I'm going to take that common denominators, I'm just going to write it in. So that's a x minus 2 times x plus 1. Okay, because the denominators match, I can then subtract the numerators together. Well, what was the first numerator? I had x minus 2 times x minus 1. And then I also had x plus 3 times x plus 1. I guess it was red. Okay, now we've seen this before. We've seen it with addition and subtraction of with fractions, right? I don't have time to go into the example, but when you have common denominators with addition or subtraction, you just add or subtract the numerators. That's it. Okay, so I just took the two numerators, and even though I've worked on them, and I combined them with subtraction. Now we do need to remember there is a denominator, but I don't worry about that yet. Okay, so what I'm going to do now is I've got to distribute these. Now I'm not even talking about the negative one right here. I'm just talking about foiled, if you want to use foil with with these ones. Okay, so let's get started on that. Again, this is not going to affect the denominator, so I still have x minus 2 times x plus 1 in the denominator. And by the way, I'm going to keep these separated or factored, so that if I find anything that I can factor from the top that will actually make a phantom 1 with either one of these, that's good. You're welcome to multiply these and make a trinomial, but you're probably going to have to split it up anyways, okay? So let's get started here. I got x times x, that's x squared. And I got x times negative 1, which would be negative, I'm going to show the negative 1x. Then I got negative 2 times x, which is negative 2x's. And I got negative 2 times negative 1, which is positive 2. And that was fun. And that we're going to subtract, so I'm actually going to need the next part in parentheses here. See if I can fit it. So I got x times x, which is x squared. Then I've got x times 1, which is positive 1x. Then I've got 3 times x, which is positive 3x's. Then I've got 3 times 1, which is positive 3. So I barely fit that in. Wow, that was fun. Yeah, definitely. So let's give ourselves a little bit more space here. See if we can stinking technology. Okay, so now I'm gonna take this and I'm gonna do even another step which you may or may not choose to show. I'm gonna show it though, because it's so much fun. And again, the denominator, none of this is affected by the denominator yet. Something may, but not yet. So x minus 2 times x plus 1. But I've got that right here. It's minus, so it's a negative 1, which we've seen before, right, with subtraction of these. Some students would say, well, can't we just combine these like terms? Yeah, but I'm going to wait. So if you want to do that, that's fine, but I'm not going to do that yet. Okay, so let's write everything in first. So I got, you know what, I skipped that. We'll come back to that. So from that distribution, I've got a negative 1x squared, and then I got a negative 1x, then a negative 3x, and then a negative 3, okay? So that's just from the distribution. We still have all the green terms in there, the x squared. If you want to show the 1, that's fine. And then you got the minus 1x minus 2x, and then plus 2, okay? So we did the distribution, then we did distribution, and then now that we have a fairly large expression, we are now looking to combine any like terms that are on this thing. And since we're having so much fun, it's good news. So on this one, we're still just in the denominator, but from this, so I got an x minus 2, still the denominator, right? Just keep that there. But in the numerator, what I see here is my 1x squared and my negative 1x squared. Those become a 0. They zero out. Now, on the other hand, though, I've got x's. I've got some x terms here. I've got negative 1x, negative 2x, negative 1x, and negative 3x. So in x's, that's like taking negative 1, minus 2, minus 1, minus 3, which I think I count as negative 7 x's. Okay, and then we have the constants of 2 and negative 3, which when I combine, I get negative 1. Well, so as fun as that was, however fun you think it was, that's just the start. Because, well, not the start. Really, we're not even. I feel like I want to give good news here, like we're halfway done. We're not, because we still got. Not only do we have to do the denominator, but then we're gonna have to switch this into a division problem, and then multiplication, and then look for simplification. Is it going to be rough? I don't know. I don't know. Well, let's look at that denominator now. So I need the denominators to match, right? In the denominator. By the way, I got x minus 2, x plus 1. Okay. So again, I need the denominators to match so that I can actually add these together. So let's go ahead and do that. I'm going to take my x minus 2 right there, and I'm going to multiply it into the other part there. Now, I'm not covering the numerator. You're welcome to do that, you know, if it's bothering you or if you get stuff mixed up. So that x plus 1, I'm going to multiply by x minus 2, but also the numerator times by x minus 2. Okay, but by doing that, then I now need to take the x plus 1 denominator and multiply it into the first fraction of the denominator, which is same as multiplying by x plus 1. Okay, and having done this now, I've got x plus 1 times x minus 2, x plus 1 times x minus 2. Yeah, those match. Okay, so again, is this more steps than you'd ever show? Perhaps. I can't guarantee that it is or isn't. I don't know. It just depends on how you want to do it. But at least my denominators match as x plus 1 over x minus 2.
You put this in a test.
Right. So now the numerator, again, I'm going to show this step. Would you actually show it? I don't know. But here we go. I got in the numerator, I got the x plus 1. I know it's getting kind of crowded in there, but it is what it is. That's how much room we got. So then we got a x plus 2. This one was plus. Don't forget we had a plus sign there. And then it was added to x minus 4 times. That was the x minus 2. Trying to keep my colors the same. Not just because it looks pretty, but hopefully it helps. So now that we've done that, I've got my same denominator of x plus 1 and x minus 2. By the way, the fact that these, like this denominator here, I know it's in a different order. Oh, it should be x plus 1, shouldn't it? Even though it's in a different order, we know when we change this to multiplication, I'm getting ahead of myself, but when we change it to multiplication, these are going to essentially become phantom ones with each other. We'll wait. All right. So now that we did that, let's go ahead and do some distribution. All right, x times x is x squared. X times 2 would be 2x is positive. 1 times x would be positive 1x. And 1 times 2 would be positive 2. So that's my first distribution. We are adding these together with the other distribution. So that's x times x, which is x squared. X times negative 2, which would be negative 2x's. And negative 4 times x, which would be negative 4x's. And then negative 4 times 2, which is positive 8. Now you notice on this one, I did not keep it in parentheses like this one in the numerator. That's because it's addition. And when we add terms like this together, I'm going to use the word terms, there's no need for distribution at that point. So really when I get this next part finished, that will have simplified the numerator for us because there's no need for distributing a positive 1. So let's just combine the like terms then, all right? Okay. Well, I got an x squared there and an x squared there. That would be 2 of the x squareds. So that's my x squareds. What about x's? I got 2 x's, another x, that's 3 x's. I'll take away 2. Now it's 1 x's, and then take away 4. That'd give me negative 3 x's. Then we got the constants of 2 and 8, positive. 2 plus 8 then is positive 10. There it is. Okay, now again, this trinomial should be simplified. So I'm just going to take that denominator and I'm just going to move it over into this next part of the fraction. That feels good, huh? Hopefully. But we got to, I don't know. It doesn't really matter when you do it, but I would like to look at that trinomial, 2x squared minus 3x plus 10. I just want to see if it can be factored, because if it can, yeah, and I'm assuming that it will. So if it can, then we're going to factor it. But since my leading coefficient is 2, I'm going to have to use factoring by grouping. So I take the leading coefficient, multiply it by the constant there. 2 times 10 is 20, positive, by the way. But I need 2 factors of 20 that can add up to negative 3. 1 and 20 don't work. 2 and 10 don't work. Negative 5 and 4 don't work. Yeah, so if this was just a 10, maybe we could get it to work, but it's 20. There's no 2 factors of 20 that are going to add up to negative 3, whether you choose 1 and 20, 2 and 10, or 4 and 5. And let's make those negative as well, just to make sure. Yeah, it still doesn't work. So this trinomial here just can't be factored. To me, it's prime. So to me, that part of it is good news, meaning once we get to the point where we can start making phantom ones and cross-simplifying, it should make that a little bit easier for us, hopefully. All right, I'm going to work my way down because if I make that any smaller, this stuff's going to fade off into oblivion.
Very easy to follow.
Which maybe we want. So on this one, let's take that numerator, right? The negative 7x minus 1. And then we got the denominator of x minus 2. Do it slightly better. There we go. X minus 2 times x plus 1. But I'm changing this now into a division problem, which will lead into other things. But then my numerator there is 2x squared minus 3x plus 10. All over, I had it written as x plus 1 times x minus 2. Now, again, if the order of these makes a difference to you, like you say you want them to match, well, feel free to do it. It doesn't matter to me because I'm going to change this into a multiplication problem anyways. So let's get that first one written out. And let's change that division to multiplication by reciprocating that first fraction. So now I got a x plus 1 times x minus 2. That's my numerator now. And the denominator is still 2x squared minus 3x plus 10. All right. Now, you know, we're so close. We're so close. Just don't give up yet. Well, I say yet, but maybe you gave up a long time ago. In any case, now I can find any matches in the numerators and denominators. I got an x plus 1 and an x plus 1. Boom. Those become phantom 1. Cross simplified. Same with this x minus 2 with this x minus 2. Boom. Cross simplified. Now, again, we already checked this 2x squared minus 3x plus 10 to see if it could be simplified, but it cannot. So it's going to remain in the denominator, 2x squared minus 3x plus 10, and the negative 7x minus 1. Again, could you factor that out? You could factor out a negative 1 there. Sure, you could. But it's not really going to do anything in terms of this particular problem, so I'm just going to leave it alone, and we're going to call that good.